taking a look at some angle properties here. Okay. The big one that we're going to look at today is called a bisector. Okay. So if I take an angle, okay, so we're looking at angle MPR, and I'm going to draw a bisector. What do you think bisector or bisect means? So, two, yeah, so bi means two, right? So bisect means to cut into two pieces, okay? But even more specifically, it means to cut into two equal pieces. Okay? A bisector is something that cuts exactly in half, to where each half is equal. So in this figure right here, PN, okay, ray PN, is an angle bisector of angle MPR, right? So just for notation again, that we talked about yesterday, remember to denote a ray, we start at the end point, and then pick another point on there, and then put a line with one arrow over top, so that would be naming ray PN here. We're saying that is the bisector, okay, the angle bisector. So that's the big vocab word for today, angle bisector of this angle. Means it cuts it exactly in half. Okay. Another word that we have mentioned before, okay, we'll work with this idea a lot more as we keep going forward, is congruent. Okay, I said this angle bisector cuts this angle into two equal pieces. PN is the congruent PN is the angle bisector. So the two congruent angles then would be angle MPN and RPN. Okay. These two angles would then be congruent, and congruent just means the same, right? For what we're doing right now, we can think about congruent as meaning equal, but when we start getting into more geometric figures, okay, congruent is going to be same size, same shape, okay? And we can start to think about that with angles here as well, right? So if we jump down to this notation here, okay, this is what Kodak just asked about, right? The two equivalent angles, or we can say congruent. So this symbol right here, the equal sign with the squiggle over top, that means congruent. Okay, so you want to make a note, okay, circle that, make a note on your paper that equal sign with the squiggle over top means congruent, right? Which for our purposes right now just means the same. So an angle bisector cuts an angle exactly in half. So what we're going to do is start to solve some algebraic problems with this idea. Okay, so let's look at the example here. So it says, look at the figure, and we're told that the measure, so I guess another little notation thing, if we've got an M in front of an angle like that, that just means measure. Okay, so if the measure of angle MPN is 2x plus 14. Okay, so in my diagram, we're saying angle MPN is 2x plus 14. Okay, so this angle right here. And then the measure of angle NPR, so NPR is this piece, is x plus 34. We want to set up and solve an equation for x. Okay, so what we know is that PN bisects, or cuts in half, this larger angle. So what do we think? How could we set up an equation here? If I have expressions for each half here, for each piece that's created, for each angle that's created, how could I set up an equation that relates those? Exactly, right? If those are going to be equal. So I'm just going to take these expressions and set them equal. So 2x plus 14 equals x plus 34. Okay, take a minute, solve that for me. x equals 20. So is that all I have to do for this problem? What do I still need to do? Yeah, I need to plug that answer of 20 back into my expression for NPR. Okay, well, my expression for angle NPR is x plus 34. So we can say the measure of angle NPR is equal to, we now know that x is equal to 20. Okay? So I'm just plugging 20 in place of that x. So it says find x, and then also find the measure of NPR. Right? So once we find x, we have to plug it into our expression for the angle of NPR. We should get that that angle is 54 degrees. What would the measure of angle MPN have to be? What is it? 54, right? We said these two angles are the same. So if we get that one's 54, the other one has to be 54 as well. Right? And if we plug 20 in, we should get 54. 2 times 20 is 40, plus 14 is 54. Okay? So that's one way to double check yourself. Right? Is if we get our answer and we plug it into both sides here, we should get the same answer. All right? Questions? Okay, so the big idea is an angle bisector cuts an angle exactly in half. So we can say those two halves would be equal. Okay, so let's jump down and take a look at number 1 together here. Okay, this one is slightly different. We're still using these same ideas, okay, but the setup is going to be a little bit different. Okay, so it says in this figure, QP and QR are opposite rays. What does that mean? What does opposite rays mean? Yeah, just going in opposite directions, right? So they would create a straight line. Then it tells me that QS, so this ray right here, bisects angle PQT. So that means it cuts it exactly in half, right? That means that these two angles would be the same. To denote that on a diagram, okay, we're going to see this for the rest of the year. We can put the same number of arcs inside of those two angles. So if I put one arc in each of these angles on the diagram, that tells me they're the same. Okay? We talked about a little bit before, okay, if I've got two line segments and I put the same number of little tick marks on them, that tells me the lines are congruent. The notation for angles is putting the same number of arcs inside. Okay? And we'll deal with this figure notation a lot more as we go. Okay, this is just kind of our introduction to it. So we could set up an equation and say, well, you tell me, what would the equation look like then? To solve for x. Sebastian?
4x plus 14 equals 30.
Yeah, 4x plus 14 equals 30. All right. So,
You said 14?
What's that? So I think we should get 4 for that one. Is that all I need to do for that one? It is, right? The question just says find x, right? So that is all I need to do for number 1. Now let me show you another way that we could have done this. Okay, this way it works perfectly. We get the right answer. Okay. Another way of thinking about this is saying, well, if I know these two angles are the same, if this one's 4x plus 14, this one would also be 4x plus 14. Right? They're the same. So another way, and this way is actually more work. Okay, but sometimes we'll need to use this way because we'll be given different pieces of information. We can say that these two pieces added together, right, 4x plus 14 plus 4x plus 14 equals that whole angle of 60. And when we solve this, we'll get the same answer. We'll get x equals 4. All right. So just two different ways of approaching this, right? We could either, like Kodak said, cut this 60 in half, and say 4x plus 14 equals 30, or we could say, if this is 4x plus 14, this is also 4x plus 14, add those together and set that equal to the entire angle of 60. Okay? Questions? All right. Let's see. What's up? So we're saying, so if
There's
this
two
angle,
different ways to do it.
yeah,
I like how
yeah, and that way in this case is definitely shorter and easier. Yeah, we will see some problems though where we'll be given maybe an expression for this instead of a number, and it will be a lot more difficult to take half. Like if this were x plus 2, right? That would be a lot more difficult to just take half of x plus 2. Right? No questions? All right, then you guys try number 2 here. Okay, same diagram, but we can get rid of all of these numbers, right? We're using completely different numbers for number 2, so don't try to use the numbers from number 1 here. Natalie? Sure. Well, so this, you can't look up here. So, yeah, equaling half given the expression. Relationship. What are you confused about? Number 2. So it's saying PQS. So PQS is this angle right here. Is 3x plus 13. And then it's saying SQT is 6x minus 2. So from that information, we want to set up and solve an equation. So what we know, right, is that ray QS cuts this larger angle exactly in half, meaning these two angles are the same. They're equal to each other. So how could I set up an equation here? Yeah, minus 2. Yeah. All right, I'm hearing a lot of 5s for x. Okay, so are we good with getting that far? So then the question asks us to find the measure of angle PQT. Once I find that x is 5, how would I do that? How would I find the measure of PQT? Because if I'm looking here, I don't have an expression for PQT. JT. So yeah, let's start by finding PQS. So the measure of angle PQS, this piece right here, is going to be 3 times 5 plus 13.
where do you see all this room for us to write on it?
Yeah, I know there's not a lot of room on your paper. Alright, so 3 times 5 is 15, plus 13 is 28. So we get that this angle, bless you, is 28 degrees. So how does that help me find PQT then? Yeah, so if I could also plug 5 into this one, right? Or I could just say, well, if these are equal, and this one's 28, then this one would have to be 28, and then I can add these together. So 28 plus 28 gets me that my final answer, the measure of angle PQT, should be 56. 28 plus 28. Okay. So this one, the setup, okay, was just like we've been doing, right? If two angles are, or if we have an angle bisector, those two angles are equal. So set the expressions equal and solve. But then we had to think a little bit how to answer the final question, right? If we want the whole angle, PQT, this is how I would have to solve it. Questions? All right, let's jump down to the next diagram and try some of these then. Okay, so what we're told is that BF bisects CBE. Okay, so that tells me that these two angles are the same. Okay, if BF bisects CBE, these two angles would have to have the same measure. Okay, so take a look at what we're given at number 3. Try to set up and solve an equation here.
So is this x plus 4 equal to something else?
Yeah, if you're done with 3, go ahead and keep moving on. You mean like once we find x, find this part? Yeah. Okay, well, so in this one it says we want to find EBF. So in this case, we have an expression for EBF, right? It's 6x plus 4. So what'd you get for x? So you're just going to take that expression and plug 4 in place of x. So we'll have 6 times 4 instead of the x plus 4. Like that.
Not really. I don't really understand anything. I got that part. Yeah, next to 6. It says find the measure of EPF. So find the x is 1. Then you take 6 times 6. Oh, 6.
Well, for this example, we don't have something whole angles equal. All we have are those fractions.
So we could
Right.
I don't like it. Come here.
Yeah, go ahead.
That's okay. Yes.
You guys.
Just fresh up.
I'll break up fights.
Well, yeah.
I know it's close. I know it's something. That's what I said.
So we've got ABE, this whole thing. But then it says ABD, just this piece right here. So we can't say that this thing is equal to this thing. Those would be, but what we can say is if this whole thing is 100, it's 50. Well, 2 times r plus 5 equals 5. Solve it.
That's why it takes.
What are you doing? I'm just saying that we're walking up the hall. Like she is her that one dad did not play.
How are you today? Good? Better.
Sure.
No, I got really bad yesterday too. I went shopping and got some rings out there.
I was just something like stuff. I'm sorry for being emo, so.
Aw, good. I've not seen that since like March. Yeah, the zebra. Yeah, the gum where you like lick yourself and make yourself happy.
Like juice hot. That's the best one for 30 seconds. It's got an XR7 or an XR8.
Yes. Thank you so much.
Yeah. It's an XR8.
My favorite of all time is candy bubbles. I love candy bubbles. Watermelon biscuits are I don't do as much for like knocks my jaw. Like
Sometimes my recognition. Because you know when you brush your teeth and you do something.
that was not a good idea. I don't wire you for that.
I was like, what do you want to drink? Because before we did
So that's a good
I give her my pocket measure about my house and my yeah. She got me the wrong box.
we have to find measures. So already knows this is a 4x plus R. Once you get your answer, then it's like that.
They made me call out a chant. And I was like, one job. She's like, I was like, my voice around, and we all started laughing. One job in art camp. This was taking straight. They said that they might have one job. They don't always. My 89 cent no I got like yeah, we have to wear the head.
Okay. Give me just a second. Do I have that? I don't have that up. We're going to do a couple of problems for
Side 8. Right? And then for the little I kind of like the hair.
So,
Yeah.
There you go. That's surprising. Well, that's good.
All right, let's take a look at one or two of these real quick. Okay. I think I want to do number 5 together here real quick. So on number 5, we are told the measure of angle 3 is 6y plus 2, and then the measure of angle 4 is 8y minus 14. My ultimate goal is to find this whole angle here, okay? But what I know, okay, I'm told that BF is a bisector, so I can say these two pieces would be equal to each other, right? So 6y plus 2 equals 8y minus 14. To solve, I'll get my y's on one side, so I'll subtract 6y over, and then get my numbers on the other, so add 14, we get 16 equals 2y, divide by 2, and we get that y is 8. But the question wants me to find CBE. So CBE is this whole thing. To do that, I want to start by finding just 1/2 of the whole thing. Okay, so I can plug 8 in here. So 8 times 8 minus 14. Yeah, it's
Did it break?
Yeah, number 5. So we would get 64. We would get 64 minus 14 is 50 degrees. So that tells me this piece right here is 50 degrees. Well, if this is 50, then this will also be 50 degrees. So the entire measure of this angle, the measure of angle CBE, would be 50 plus 50 is 100. Okay, now, in this diagram, the way this is drawn, that's definitely not 100 degrees, right? That's an acute angle. So in geometry, okay, as we go forward, we only can look at what we're given. We can't just say, well, the diagram looks like this, so that's the case. Okay? Even though the diagram's drawn like this, okay, we still got our answer of 100. The diagrams aren't always to scale.
Yeah.
Okay? So, 5 problems for homework, right here.